Hey there, group. Here's a video for you on compound molar masses and then using the compound molar masses as a conversion factor. The objectives that this video is going to cover, here are the objectives for the entire section. We're actually going to get a video later that's going to take care of these, so don't worry about these ones right now. The ones we're going to worry about is calculating the formula mass or molar mass of a given compound. We're going to focus on that one, molar mass, and then using that molar mass to convert between mass in grams and then the amount of moles of that compound. You have your guided notes. I'm going to go ahead and pause here and make sure you get this down so you know what the video is all about. Okay, there you go. Make sure you get those two objectives from the previous slide in your notes. This here, the molar mass of iron. Remember, we went to the periodic table and we realized for every mole of iron there is 55.85 grams. That on the periodic table is right here, known as the atomic mass, which is an AMU, or the molar mass, which is in grams per mole. We're going to be looking at the grams per mole because that's going to be much more effectively useful for us. Okay, so taking that same concept of grams per mole, this is how we find the molar mass of compounds. Okay, so what we have here in iron chloride, FeCl2, remember, iron plus 2, Cl, the anion, minus 1, so 2 chlorides for every iron. Here's what we do. We break up that compound into its individual elements. So we've got iron, and then we've got chloride. We then count up the number of atoms. We have 1 iron, but then we have 2 chlorides, 2 chloride ions. And then we go ahead and look at the atomic mass of each element. For iron, if we go to the periodic table, iron has a atomic mass of 55.85 grams per mole. Okay, and then chlorine or chloride ions have 70. Oops, excuse me, I take that back. Getting ahead of myself here. Chlorides are 35.45 grams per mole. Now here what we do here is a little multiplication. So for the 1 atom of iron, we keep ourselves 1 times 55.85 gives us again 55.85 grams per mole. Okay, but then we have 2 chloride ions, so we multiply the 35.45 by 2, and that's the molar mass in the compound. If you see in the compound, there's that 2 here. So the molar mass in the compound. So 2 times that gives you, there's that 70.90 grams per mole. Now all we got to do is we have to add it up, because we have 1 iron plus 2 chlorides, so we have 1 iron plus 2 chlorides, and we add it up, we end up with, a pen will work here, 126.75 grams per mole. And that is the molar mass of iron chloride, iron 2 chloride. Okay? I would love for you to try this one, zinc bromide. Try this one on your own, and then I'll show you the answer. Okay, hopefully you've paused and you've got a thought of what you think it is on your own. Go ahead and check against this. Does it look the same? If not, where did you goof up? Remember, this is from the table, periodic table. Okay, and then these are multiplied to equal that, and then these values are added down to get the total. If you notice here, this is an AMU, okay? And essentially, we're going to, for functionality, AMU is going to be interchangeable with grams per mole. Okay, AMU is the formula mass, grams per mole is the molar mass. Numerically, they equal each other. So 65.39 AMU equals 65.39 grams per mole. So don't worry about that. Okay, so one more. Let's do potassium sulfate. What's the molar mass of potassium sulfate? Uh-oh, we've got some naming here. We got potassium sulfate. I know the potassium ion is K plus. I know sulfate is my polyatomic. That's SO4 -2. So to make potassium sulfate, I've got to cross my charges, and I get K2SO4. All right. Now let's just grill through. So I've got potassium, I've got sulfur, and I've got oxygen. I've got 2 potassium, 1 sulfur, and 4 oxygen. When I look at the periodic table for atomic mass of the elements, I see potassium at 39.10. I see sulfur at 32.07. And I see oxygen at 16.00. I multiply those through. 4 times 16 gives me 64. Add them up, 3 to the bottom, and I end up with 174.27 grams per mole. And that is my molar mass of potassium sulfate. That skill right there has become very important over the next couple chapters, so make sure you pause, rewind, go back through this, do a couple more practices for yourself. You can actually make them up. Just make up a compound and practice, and then see if you're doing this grid properly. The second step of this video is using that molar mass of the compound as a conversion factor. Here's the good news. It's an old skill. We've been doing it. We've been using grams to moles to atoms, atoms to moles to grams. So it's an old skill, but there's a little bit of a twist. And here's what the cool twist can get us. Look at this question here in yellow. You're going to be able to answer questions like this. Ibuprofen is the active ingredient in many non-prescription pain relievers. How many moles of ibuprofen are in one bottle if you've got 9 33-gram bottles? Okay? So we're going to be able to answer questions like that. Here's how we're going to do it. First, what's a molecule? Okay? Because we're going to be using molecules now. Here's a couple examples. Here's a water molecule. 1 oxygen, 2 hydrogens hanging out. Chocolate, theobromine, essentially. This is what makes up chocolate, this little picture here. And then we've got these things, testosterone, estrogen. These are inside our body. We've heard of these. These are also molecules. They're molecules that exist throughout. Any stop here without a line actually equals a carbon. So there's a carbon there, a carbon there, a carbon there. Don't worry about that now. But that's what a molecule looks like. So a molecule is the elements bonded together to make a new thing. You can see testosterone, estrogen, very different, but if you look at them, very similar. Only big difference I see is an OH group here and an O there, and then a methane coming out of here that doesn't exist in the estrogen. Really, that's the only big difference. Okay, so get these notes in here. This here is the old stuff. We know this. Element molar mass is grams per mole. Okay, and that allows us to use this conversion factor here. That blank is just there because it's different for each element. All right, so we can go grams over moles or mole over grams. We also know this one. This is Avogadro, my man AV. Okay, Avogadro's number, 6.022 times 10 to the 23rd atoms, is in 1 mole. So we get to use this conversion factor. And then that way we can go all the way from grams to moles to atoms, or back from atoms to moles to grams. That's what we know. The new tools is very similar. we just learned how to do this. Okay, we just learned how to do compound molar mass. That's the grid we just did. And so now we can take a compound's molar mass and use the same conversion factor. With that grid, take the grams per mole of the compound and use that conversion factor. This is the one that gets really tricky. Look at this word here, molecules. We're taking Avogadro's number and saying if 6.02 times 10 to the 23rd atoms, okay, is 1 mole, then 6.02 times 10 to the 23rd molecules, make sure those are up in your notes, I apologize for that, molecules also equal 1 mole. Wrap your head around that a little bit, make sure you have these written down, okay, and then we're going to use them. But essentially now we're going from molecules over moles instead of atoms over mole because molecules are made up of atoms. For the visual learners, here you go. This is the old stuff. Here, we go from grams to moles to atoms. All right, and back again. Here's the new stuff. We go from grams of a compound to moles of a compound to the molecules. And these, as you can see, are multiple things stuck together. So you've got the number of molecules. This is supposed to be, I think, a water there. And this is just the elements. Okay? So you can use Avogadro's number as a nice conversion factor as well. These are these train track problems, excuse me. Okay. So how do we use it? Here's a one-step problem for us. I'm going to do it for you. Okay? Watch me do it. Press pause, get it into your notes, and see if you understand it or do it with me. We have 3.04 moles of ammonia, which is NH3. First thing I want to do is I want to start with what I have. Okay? So I'm going to write that right there. I have 3.04 mole NH3. I'm then going to do my train tracks. And I want to get to mass, which is grams. That's kind of nice because I know how to go from moles to grams. I've got 1 mole NH3 over gram NH3. That way I can cancel out my moles and I'm left with my grams. But I've got to calculate my grams. Okay? Remember that grid we did before? The molar mass of the compound. Let's figure that one out. On ammonia, I've got 1 nitrogen and 3 hydrogens. Alright? I multiply that by the molar mass of the element. So nitrogen is 14.01 grams per mole. Hydrogen, 0.001 grams per mole. Multiply those out and add them together. Now remember our sig figs I'm adding here. I got my decimal places there, tens, hundreds. So I'm not going to worry about that 3 because that's as tight as I'm going to go. So add this together and I get 17.01 grams per mole NH3 ammonia. And then I can go ahead and bring that value, put it up in here. 17.01, multiply that through, and I end up with, in 3.04 moles of ammonia, there are 51.7. I stop at 7 because that's 1, 2, 3 sig figs. I started with 1, 2, 3 sig figs here. Grams ammonia. And that's all there is to it. It's just a one-step train track, but now instead of using an element, we're using a compound. I want you to try this one first. Press pause, try and do it on your own. I'll show you the answer in a second. Okay, hopefully you've pressed pause. You've got an answer written down. Go ahead and check it against this one here. I started with what I had, my 3.85 grams sulfur dioxide. Here are two nonmetals, so it's a covalent compound. And I went from grams to moles using my conversion factor. The conversion factor I got was down here. All right, 1 sulfur, 2 oxygens, add that up, I get 64.07 grams per mole sulfur dioxide. Enter that here, multiply by 1, divide by that, and I end up with, in 3.82 grams of sulfur dioxide, there are 0.596 moles sulfur dioxide. Again, a one-step problem using the train tracks with just a different conversion factor. A two-stepper. These ones we get tough. We are going from grams to moles to molecules. On this one again, let me walk you through it, okay, and then pause and get in your notes afterwards, or just follow with me now. Start with what I have. I have 77.1 grams Cl2. Chlorine's a diatomic. We'll talk about that later. And I want to get to molecules. I can do this multiple ways. I can set up my tracks right now. Okay, and I know if I have grams on the top, I'm going to put grams on the bottom. Don't forget your units. I use my mole, middleman mole. Okay, I always know that mole. I just got to fill in this value here. And then I know I can go from moles to molecules because 1 mole Cl2 is equal to 6.022 times 10 to the 23rd molecules. Okay, so I can set that up, and if I see I've got an open spot here that I need to fill, and remember I get that by getting the molar mass of my compound of Cl2. Well, that one's kind of nice. All I have in it is chloride atoms. I've got 2 of them, so I multiply the 2 by the molar mass of chlorine, which is 35.45 grams per mole, and I get that to come out to 70.90 grams per mole Cl2. Take that number and put it here. Okay? 1 mole equals 70.90 grams Cl2. Multiply that through, and I end up with how many sig figs? Only 3, because I've got 1, 2, 3 sig figs here. Gets me 6.55 times 10 to the 23rd molecules Cl2. And I circle my answer there. Boom. There's a two-stepper. Same skills we've been doing, just a new twist. I want you to try this one on your own. Press pause. Try this one out. Okay, hopefully you've got an answer there. Tell me, does it look like this one here? Did you start with what you had? You had 4.099 times 10 to the 23rd molecules of hydrochloric acid, HCl. So you start out with that. Convert molecules to moles using Avogadro's 6.022. And then you go from moles to grams, because down here you found the molar mass of HCl by breaking it up, adding it up, getting 36.45 grams per mole, and putting that up in here, and you ended up with, in 4.099 times 10 to the 23rd molecules of hydrochloric acid, you have 24.81 grams hydrochloric acid. Please make sure you have those notes filled out. And as I said, you're going to be able to answer questions like this. This is on your sheet. I would like you to, before you come to class, try and have an answer to this question, and we'll start next class by going over this question here, using your answers. Hopefully you guys have an idea of where to start and where to go. Thank you.